Welcome to this explainer. Today we're unpacking the Vikram Tutor's Guide to Measures of Central Value. So if you're looking to really master statistical analysis, you are in exactly the right place. We're going to break down some incredibly useful concepts straight from the source material and, turn them into totally actionable steps.
All right, let's just dive right into this. Think about it. How do you find the most popular data point hiding inside a really complex frequency table? When you're staring at a massive wall of numbers, finding that most recurring, popular data point, well, it isn't always obvious, especially when that data is grouped into intervals. So today we're going to demystify exactly how to pinpoint what we're looking for without getting completely lost in the weeds.
And to do that, we are dedicating this entire explainer to mastering one very specific, highly powerful measure of central value, the mode. In statistics, you'll usually see this represented by the letter Z. Now, while finding the mean or the median tells you about the average or the middle, finding the mode tells you about the absolute most frequent occurrence in your dataset. It's basically the MVP of your data.
Okay, let's get into it. Step 1. Find the modal class.
So the crucial point here is understanding what exactly a modal class is before we do any heavy math. By definition, in our source text, the modal class is simply the class interval associated with the absolute highest frequency in your dataset. Think of it like a neighborhood. It's the specific neighborhood where our mode, Z, currently lives. We just have to find that neighborhood first.
Let's actually apply this to a real scenario using question 5 from the Vikram Tutor's question bank. In this dataset, our variables labeled X represent our class intervals, and Y represents our frequencies. Now, to find our modal class, all we have to do is scan that frequency row to spot the single largest number.
So scanning across those Y values, we see 20, 24, 32, and then boom, 34. Since 34 is clearly the highest frequency in the dataset, we just look at the interval associated with it. That gives us our target modal class of 30 to 35. See? We've officially found the neighborhood. Moving right along, step 2, extract the variables.
Now we actually need to pull specific variables from the class we just identified. Think about that 30 to 35 interval we just locked in on. We also need to grab the frequencies immediately preceding it, which is 16, and succeeding it, which is 10. We're isolating these specific numbers because, well, they're the entire cast of characters we need for our formula.
All right, here is our variable checklist, perfectly laid out by the source text. First, we need L1, which is the lower limit of our modal class. We need F1, the frequency of our modal class. Then we grab the prequel frequency, F0, which is the class preceding ours, and the sequel frequency, F2, from the succeeding class. And finally, we need C. That's simply the width of our modal class interval.
Watch how easily those kind of intimidating algebraic variables map directly to the numbers we just isolated. Our modal class was 30 to 35, right? So our lower limit, L1, is 30. Our star frequency, F1, is 34. The neighbor right before it, F0, is 16, and the neighbor right after it, F2, is 10. And since the gap between 30 and 35 is exactly 5, our class interval C is 5. Honestly, it's really that straightforward.
All right, step 3, apply the formula.
I know, this mathematical formula might look like a totally scary puzzle at first glance. But really, don't let the grouped mode formula intimidate you. It's literally just a simple recipe waiting for the ingredients we just prepared. Let's walk through it together. Z equals L1 plus a fraction. The top of that fraction is F1 minus F0. The bottom is 2 times F1 minus F0 minus F2. And then we just multiply that whole fraction by C.
By substituting our extracted numbers directly into the formula, you can see exactly how the puzzle pieces fit together perfectly. Our L1 becomes 30. Inside the brackets, the top becomes 34 minus 16. The bottom becomes 2 times 34 minus 16 minus 10. And our C at the very end just becomes 5. Everything is right in its place.
Let's actually break down the math step by step to avoid any, order of operations confusion. First, we handle the top fraction. 34 minus 16 gives us 18. Next, the bottom. 2 times 34 is 68. Subtract 16, then subtract 10, and we're left with 42. So our fraction is 18 over 42. If we divide that, multiply it by our interval of 5, and finally add our base limit of 30,
We arrive at our final calculated mode for this dataset, approximately 32.14. It is incredibly satisfying to watch a massive frequency table distill down into just one precise, actionable number. You've officially calculated the grouped mode. Awesome job.
Section 4. The Statistical Relationship Rule.
Okay, so now that you've mastered the long way, what if I told you that you didn't always have to use that big formula? We are comparing the long grouped data formula we just conquered against a very clever shortcut. If you happen to be in a situation where you actually already know the mean and the median of your dataset, you can entirely bypass that complex formula we just learned. No way, right?
Well, the source text reveals this really elegant relationship between the measures of central value. Z equals 3m minus 2x bar. Or, in plain English, the mode simply equals 3 times the median minus 2 times the mean. This beautiful little equation just shows how intrinsically linked these central values really are.
I'll leave you with this provocative thought as we wrap up. How could you use this simple equation to quickly verify complex data sets in your everyday work or studies? Just imagine calculating the mode the long way, and then instantly double-checking your own work using just the mean and median. The power to really understand and manipulate data is in your hands, and mastering the mode is a huge step in that journey. Thanks for joining me on this explainer, and keep exploring those numbers.